6.1. So, can we stop talking, please? Thank you. I'm a little hoarse, so I can't really raise my voice above the din very well right now. So we're going to be talking about these inverse trig functions. And we already talked a little bit about inverses back in chapter 1. So let's say that we want to find the inverse for y equals sine x. So to do that, we're going to take every coordinate on the graph and swap the x and y coordinates, right? So if we do that, get something that looks like this. Everybody okay with that idea? So this is like x equals sine of y now. Looking at that graph of x equals sine of y, do you guys see any potential issues with that? Something should jump out at you. It's not a function. Ah, fiddlesticks. So, what did we do before when we had something that wasn't a function? Well, what we do is we go back to our original and we restrict the domain so that it'll pass a horizontal line test. So basically what we're going to do is just go from extrema to extrema, and that'll be a domain that covers all the y coordinates but doesn't repeat any. So maybe we'll go, it doesn't really matter which two we use by convention. We usually go from negative pi over 2 to positive pi over 2 is usually the restriction that we make. So if we do that, we get this graph. So this is y equals sine x, where we're just going from negative pi over 2 to positive pi over 2 for my x's. And now, we do that. We get this graph. Notice here that this now is a function, right? What's the downside here of having to done this? Well, it doesn't, yeah, it's not a complete graph. So basically what we're saying is there's going to be angle measures that we can't solve for, right? Because the only angle measures that we can solve for are between negative pi over 2 and positive pi over 2. So we can't solve for all of them, right?
Can't we just say that that it's a corresponding, that we can we get another angle outside of that? Can't we just say it's corresponding angle positive pi?
That's kind of what we'll have to do, but when we go to program our calculator, program a machine to do this, it's going to just only going to be able to give you answers that fall in that range.
Okay.
So that's the downside. So to take this forward, we're going to have to be a little bit careful about what we do. Yeah, that's f of x equals. So the domain for the sine inverse is going to be -1 to +1. Those are the possible outputs of a sine function, right? And the output of sine inverse is going to be an angle between negative pi over 2 and positive pi over 2. So where is that on the unit circle? So negative pi over 2 to positive pi over 2 is quadrants 1 and 4. So what can we do if we want an answer in quadrant 2 or 3? Let's look at an example. Let's do that, I suppose. So let's say we want to find the theta whose sine inverse, or whose sine is equal to -1/2. And we're located that, and the theta we want is the one that's between pi over 2 and 3 pi over 2. So the first thing I'm going to do is kind of draw a picture to figure out where I'm looking for my angle theta. So 0, pi over 2, pi, and then 3 pi over 2. So I'm looking for sine somewhere over here. Everybody's okay with that? I'm going to go back to some chapter 2 idea and remember that all silly turtles crawl. So I know in the second quadrant, sine is positive. And in this problem, I need sine to be negative. So it can't possibly, the angle I'm looking for, be in the second quadrant, right? In the third quadrant, though, sine could certainly be negative. So the theta I'm looking for is here. Tommy?
Can you explain all silly turtles again? I just don't understand.
So it's just like an acronym to remember which functions are positive or negative in the quadrant. A is for all, so all your trig functions are positive in quadrant 1. S stands for sine, so sine is positive in quadrant 2, but cosine and tangent are negative. T stands for tangent, so that's positive in quadrant 3, so sine and cosine are negative. And then C stands for cosine, that's positive in quadrant 4, so sine and tangent are negative.
Gotcha, thank you.
You're welcome. Blake.
Okay, so, but why would sine be negative if it was in between pi over 2 and 3 pi over 2? Oh, wait. Okay, yeah, no, still, why would sine be negative?
Because I have a negative number I'm taking the sine inverse of.
Oh, okay.
right? Isn't this equivalent to saying sine theta equals negative 1/2?
Yeah, that's true.
So that's why I know sine has to be negative.
Okay, yeah. I get it.
Is that cool? Okay. Is everybody on board with kind of what we've constructed so far? All right. So this angle now that's formed between the positive x-axis, or I'm sorry, between the x-axis and the terminal side of my angle, I'm going to refer to as theta. Everybody's okay with that? I'm sorry, as alpha. Excuse me, that's what that symbol is. I misspoke. Cool with that? And alpha is just going to be the value of theta as if it were in the first quadrant. So that'll be sine inverse of the absolute value of negative 1/2. So it'll always be a positive, the thing that you're doing the inverse on. So now, what's the relationship here between theta, pi, and alpha? Well, pi plus alpha has to equal theta, right? Everybody agree with that? So this is pi, this is alpha, that should be theta then. Everybody agree? So now I can go to my calculator, and I can do pi plus sine inverse, and I'm just going to do positive 1/2 rather than typing the absolute value into my calculator. That's something I can certainly do in my head. The absolute value, negative 1/2. I need to make sure I'm in. What's up?
Can you type in the absolute value of the calculator?
Yeah. Got to make sure I'm in radian mode. So I get about 3.67. Math, number, option 1 is absolute value. That's ABS.
Huh.
As an aside.
You just did the absolute value, right?
I just did the absolute value in my head because I can take a negative sign off in my head. You know, it's not worth the buttons to put it into the calculator. Is everybody okay with that idea? So far, so good? Now, alternatively, I recognize negative 1/2 as a unit circle value. Right? That was a value that came up on the unit circle. So alternatively, what I could do
Well, would it be like 7 pi over 6 then?
is I can go to my unit circle, look in quadrant 3, find the place where the y coordinate is negative 1/2, and that should be my value of theta.
Oh, okay. So it's just you just grab it.
And just to confirm that, if I go to my calculator, if I do 7 pi divided by 6, I do indeed get the same decimal. Now, will I be able to go to my unit circle every time?
No?
No. Why not?
No. Because there are values that are going to be given out.
Yeah, there's lots of values that not on the unit circle, right? If I did sine of 0.7 or sine inverse of 0.7, unit circle is not going to help you out a lot there, right? Do you want to do another example here? Let's do another, yeah?
Yes.
Okay. All right. So let's say we're going to do sine of theta equals 0.125 where we're going to go from 5 pi over 2 less than or equal to theta less than or equal to 7 pi over 2. Everybody so far so good? So I'm going to start by kind of just drawing my picture and figuring out what quadrants are 5 pi over 2 to 7 pi over 2. So half a pi, 1 pi, 1.5, 2, 2.5, that's 5 pi over 2. Then we're at 3 pi, and then we're at 3.5, so 7 pi over 2. So again, we're talking about quadrants 2 and 3. Everybody's okay there? I think about all silly turtles crawl. And since sine in this case is positive, I know that my angle theta has to be in which quadrant? 2 or 3? 2. Everybody's good with y? So S tells me that sine is positive in the second quadrant, so that's why I chose to put in the second quadrant. In the third quadrant, tangent is positive, so sine and cosine are negative, so I know it's not going there. Everybody so far so good?
When you're doing the
90 degrees is half of a pi, so I just count it around. So far so good? Okay. So this is my theta. Oops. My pen stopped. There it goes. This is my theta. Again, my alpha I'm going to draw in here is always going to be the terminal side with the x-axis, the acute angle made by the terminal side in the x-axis. And now I want to relate theta, alpha, and 3 pi together. What equation relates those three together? Theta plus alpha is equal to 3 pi. Or if we rearrange it, I'd say that theta is equal to 3 pi minus alpha. Tommy?
So why is the last one plus alpha, this one's minus alpha?
So if we look at the picture, so we went theta, right? And we go alpha more, ends at 3 pi. As opposed to this one where I went pi and then alpha gets me to theta. Yep. And now it's just calculator time. So that is going to be about 930 radians. I promise I'm not dying. So you notice one of these we ended up adding alpha and the other we ended up subtracting alpha. The easy way, at least the way I like to do it to remember this, is if the last axis that theta passes through is a vertical, it's going to be subtraction. If the last axis that theta passes through is a horizontal, it's going to be addition. So when I'm drawing my picture, I don't have to think so hard about what that little equation is. That's a visual way for you. If you're a visual person, I'm a visual person. I like to draw the picture and just like kind of understand what's going on. You know what I mean? It saves me from having to memorize stuff, which is the bane of my existence. You guys feeling okay? How is this going to change if I'm using cosine or tangent? Well, it'll change a little bit. For one, the domain of cosine is different. I'm sorry, the domain is the same, but the range is different. And for tangent, both the domain and range are different. Notice with tangent, both the domain and range are parentheses. Why did we have to use parentheses on tangents? Specifically for the range. For the domain, it's... Yeah, that's where the asymptotes are. Great. So there is no point that goes with that negative pi over 2 or positive pi over 2, because those were where the asymptotes were. So here, cosine is going to give you value or angles in quadrant 1 and 2, or cosine inverse, excuse me. And then tangent inverse still gives you quadrant 1 and quadrant 4. Like,
does the range, like so the cosine, the range of cosine is different. Does that actually like change anything? For those last couple problems that we did?
No, not in terms of the way you set anything up. No. You can still do them all the same way. Do you guys feel okay with where we're at so far? Now this skill that we're talking about here, being able to find the angle of theta using an inverse in a specific range of values, is like the most important skill from this chapter moving forward. So this is the biggest of the big ideas in terms of what we need to take forward. So we're actually going to stop here. I'm going to do a couple examples from the these first two worksheets, and then I'm going to release you guys to work on those. But we're going to take a couple, do a couple of examples here from the worksheets. Sound good to you guys? Try to find some time to do some work in class and let you guys ask questions and kind of fight through things. Luke?
So if you're
Well, it won't be pi anymore because that's not the horizontal that you last went through. It'd be 0.
So you wouldn't be able to just keep it.
Yeah, it's going to be the same thing. If it's in quadrant 1, well, I shouldn't say that. If it's between 0 and pi in quadrant 1, then alpha is theta. If it's in quadrant 1, but say it's between 2 pi and 3 pi, then you're going to have 2 pi plus alpha. You know what I mean?
Yeah.
Arya?
So why is inverse cosine
Because if we look at the graph of regular cosine, this would be the part of the domain that I would restrict, which is 0 to pi, as opposed to sine where I have to start beforehand, right? So sine we did like that part of it to go from min to max. Is that okay? So it just kind of depended on what the shape of the original graph looked like. Usually we try to restrict our domain as close to 0 as possible. Sometimes, or we want to include 0 actually. But for cosine, we can start at 0 and get the other side of it. For sine, we can't do that because you're going to, because it's the midpoint instead of an extrema. Is that satisfied? So let's just grab a couple of these boys and do them. Let's scroll through here and find a couple of goodies. Oh yeah, we should certainly do one of these then. Let's do, say, 10. This is actually kind of relates to what Luke had asked just about a minute ago. So first things first, I noticed that, hey, wait a tick. This isn't sine, cosine, or tangent. What am I going to do with this? Yeah, so I remember that cotangent is the reciprocal of tangent. Everybody's okay with that? So if I then take the reciprocal of both sides, I can say then that tan theta is equal to 1 over root 3. So far, so good? Okay. So I'll be using tangent inverse on this one. If I draw my picture, from 0 to 2 pi is quadrants 1 and 2. If I remember, all silly turtles crawl, I know then that my theta is there in quadrant 1. Everybody's good with that? So my alpha then would also be in quadrant 1. So in this case, I would want to say, okay, how do I relate theta, 0, and alpha? Well, theta is just 0 plus alpha. Or just alpha, right? But I'm going to write it that way because if this was instead like 2 pi to 3 pi, you definitely have to worry about, the thing that's a 0 because it would be 2 pi in that case. You know what I mean? Luke, is this feeling okay? This is specifically kind of what you were asking about, right? Okay. So then I'll just go to my calculator. And I'll do tangent inverse of 1 over root 3. So that's about 0.5 0.23. I can't remember if this was to the 100th or the... Or I could also do this using the unit circle, right? So if I go and I look at my unit circle, I'm looking in quadrant 1. I remember that tangent is y over x. So I'm looking for the place where the x coordinate has a root 3 in it. So it appears to be pi over 6. And just if we wanted to just confirm that, pi over 6 is the same decimal. It is. I think on the directions on this problem, I ask you to use the unit circle to do this, but I like doing it this way because it's just good practice for the other method. You know what I mean? Okay. If I look at the second sheet, let's do let's do 5. So this is cosine inverse of 11 pi, or cosine inverse of 0.19 from 11 pi to 12 pi. 5 on worksheet 2. So if I do that, so 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, and then 23 pi over 2. That's 11.5 pi, and then 12 pi is over here. I'm going to draw this now like it's a little less messy. But we know we're looking in quadrants 3 or 4 here. So far, so good. I'll go to all silly turtles crawl. So between quadrants 3 and 4, where's cosine positive? In the 4th quadrant. So that's where I'm going to draw my theta. Now, I'm not going to draw all the loops around because, quite frankly, like, it's going to be it was going to get too messy for me. So I just drew it that way. Is everybody okay with that? Really, I should have like 5 loops around and then what I drew. But like, yuckarooski, I drew too small of a picture to do that. So my alpha is there. And so what relates theta, alpha, and the horizontal, 12 pi over, or 12 pi? Yep. Or, since the last axis we crossed was the vertical, I know it's going to be subtracting alpha. You can think about it that way also, same difference. So we just go to our calculator now. Do 12 pi minus cosine inverse of 0.19. And 36.32 is our answer. Just FYI, you can check these. Even if this is not a unit circle one, we can still check this. How would you check it? Cosine of 36.32 better give me 0.19, which it does. So I'm pretty confident that I'm good. Actually, there's two phases to this check. You should definitely check to make sure that like 36.32 is between 11 pi and 12 pi. And that when you plug it in for cosine, you get 0.19. Because there are lots of values of theta that give you a cosine of 0.19. There's only one, though, between 11 pi and 12 pi that does that, though. You know what I mean? What do you guys think? Luke? 7? Is it because it has the negatives? Sure. Okay. So 0, this is negative pi over 2. This is negative pi. This is negative 3 pi over 2. So we're talking about these two quadrants. So all silly turtles crawl. So between quadrants 2 and 3, where is sine got to be negative? Between quadrants 2 and 3, the two that we've highlighted, where is sine negative? And it's quadrant 3. So there's that. So our alpha is this angle here. Here's the crummy part, though. Notice that we're dealing with negative angles. So everything about our equation is kind of reversed, right? So if I take theta, I'd have to subtract alpha to get to negative pi. Because theta is a negative angle, and negative pi is less than negative theta, so I have to subtract. So it's basically reverse rules. Since I'm passing out vertical this time, I have to subtract because I'm going in, instead of going the normal way, we're going the opposite direction. So all the symbols are just flipping. So theta is negative pi plus alpha. And then we just type her in. Remember when we do this, though, that when we do our sine inverse, I have to remember to make this number positive. So that's negative 254, really 255. Let's just check that that does indeed satisfy. And it does. What do you guys think? I think that's a good place to stop.